Hi, my name is Michaela Corson, and I am part of the Ausable project. Now, our goal for this project is to create drinkable water for many areas and countries that do not have drinkable water, such as the Philippines, who we are working with the Mercy in Action, who sponsored midwife-free clinics for women who mainly live in garbage dumps and do not have access to clean water, which will kill a lot of babies there. Now, our bio-sand filters over here have been around for a while, and mainly how they work is that 30 days a bio-sand layer forms. Now this layer has microorganisms that consume pathogens that are in the water that cause a lot of harm, such as E. coli. And it'll also have mechanical trapping occurring in that area. And then once you get further down into the filter, you have what I call the dead zone, which is an anaerobic area where there's no oxygen. And what this will do is anything that has made it through the bio-sand layer will get killed off by starvation because there's no food in that area, or they'll just die due to their natural cycle. Now once they've made it all the way through what I call the dead zone, they'll get to our pipes in the bottom, which will then, as more water is added in, push the water up and then out our spout. Now our main goal for this project is to actually build a pre-filter to protect our main filter, which is harder to clean. Now our pre-filters are designed in a 3-section system. The first section is kind of like a miniaturized version of our bio-sand filters. It has the sand, the gravel, and then the bigger gravel to protect the tubing that will bring it up. So a bio-sand layer will form in this bucket. Then there's a pipe that brings it down to our dead zone, where it will create a starvation area for whatever pathogens remain. Then after it has made it through this area, it'll go into another area that has another bio-sand layer. And here we have, for this filter, after it's gone through the bio layer, it'll have the tantalus. Now the point of the tantalus is so that if too much water gets in here, it will not overflow. It will dump the water before it overflows, which was a main problem in building it. So once it gets through the tantalus, it'll go into our bio-sand filters. Okay, the purpose for our pre-filters is to protect our bio-sand filters. What they do is they mechanically trap the pathogens, and they also have 2 biofilm layers in it that will remove a lot of the pathogens before they even get to our big filters. Now, by doing this, we save a lot of time that will take to clean the big filters, because these big filters are hard to take apart and clean. Where our system can be separated, the 3 parts can be taken apart and cleaned individually, which will make cleaning it 4 times a year easier. Alright, so with our filters, we have been doing daily turbidity tests. Now what this has shown is it gives us an estimation for what our filters are doing, what the pre-filters are doing, and what our main filters are doing. And we're also testing black sand versus red sand. We have 2 different filters here. And what we've actually sent away are testing to a lab to see what our filters are doing other than the turbidity, because the turbidity has gone down from the water that was originally put in. Now our testing has shown that the area we were getting our water from had E. coli in it, but after our filters, there is no more. So it proves that our filters are working, and hopefully as these form their bio-sand filter layers, the water quality will get even better.